Okay, section 4.4. We're going to apply the stuff that we learned yesterday. And let's draw a couple triangles. We're going to find another way to show that these triangles are congruent to each other. Let's make that go like this. I could go like, yeah, it can look like that. It's fine. Let's copy. Let's paste. Come on. There we go. Yeah, let me group that together. All right. Let's call it something else besides ABC all the time. PQR and, I don't know, XYZ. How's that sound? All right, so here is an actual theorem, not a postulate. We're applying the postulate, but here's a theorem that says this. I'll just give it to you right now, and then we'll talk about it. You have another theorem to prove these triangles congruent, okay? Remember, we don't have to show all 6 things. We don't have to show all 3 angles and all 3 sides. All right, we've learned yesterday that you could kind of shortcut it a little bit. And if you know you have a side, an angle, and a side, and that angle is an included angle, then you can say those triangles are congruent. You could also have an angle, a side, and an angle. As long as that side is in between those 2 angles, it's included, then you could say those triangles are congruent. But this says, watch this, this says angle, angle, side. You're like, well, Mr. Hammer, that's the same thing as angle, side, angle. But it's actually not. Do you see that? Where is the side on this? Is it in between the 2 angles? No, it's not. So if I have 2 angles equal on one triangle equal to 2 angles on another triangle, and I have a non-included side, then I would say those triangles are congruent because of angle what? Angle, side. So for instance, what if I told you that angle P was equal to angle X? And I also told you that angle Q was equal to angle Y. Now, yesterday, I had to say that the side would be in the middle. But today, watch this. I could say that this side and this side are equal. So that is not angle, side, angle, is it? Why does this work? It's not a postulate. This is a what? Theorem. So a theorem can be proven. And I'm going to do not a full-blown proof, but I'm just going to kind of show you why these 2 triangles are congruent. Because look, I don't really need this theorem, all right, because I can use something that we used yesterday. If I have 2 angles of one triangle, we talked about this yesterday as well. If I have 2 angles of one triangle equaling 2 angles of another triangle, tell me something about that third angle. They're going to be equal to each other. That's right, okay? So if I know this, now they didn't tell me that angle R was equal to angle Z, but they just told me that angle P and Q are equal to angle X and Y. Remember, all 3 angles add up to what? 180 degrees. I think this is the last thing we talked about yesterday. I think at the very end, I think we talked about this. So all 3 angles add up to 180, correct? These 2 angles add up to the same thing as these 2 angles add up to be, right? So really all I'm doing is what? I'm taking 180 minus this number, and this angle is going to be 180 minus the same exact number. So guess what we're going to be left with? 2 equal angles. Yes? No? Yeah. I'm getting confused looks. Let's say this was 100 degrees. Let's say this was 30 degrees. All right? The numbers will make more sense to you. So what's angle Y going to be? It's 100, right, because they said those 2 angles were equal. What's angle X going to be? 30. Now, let me show you this. What's 130? 100 plus 30? 130, okay? So what's angle R going to be then? It's going to be 50. How'd you get 50? Right, 180 minus 130. So that would be what? 50. So automatically, what's that going to be? 50, because you're taking away the same thing from 180, aren't you? So you're going to be left with the same thing. Yes? Yeah. Okay. So check this out. Without me even knowing this angle side thing, if I know 2 angles are equal to 2 angles here, that means that this angle has to be equal to this angle. And then if we wanted to, we could go back to yesterday's theorem. Why are these two triangles congruent? Because of what? Angle, side, angle. Do you see that? So did we really even need the angle, angle, side? We didn't, all right? But the thing is, you don't want to have to do that work every single time, right? Adding these up, taking them away from 180, adding them up, taking them away from 180. So instead of doing that every single time, they just came up with this theorem and said, hey, look, if you don't know anything about this angle down here, and you didn't know anything about this angle down here, but you just know that you had two angles equal to two angles, and a non-included side equal to another non-included side, then these triangles are going to be congruent. Does that make sense? Even if you don't understand the explanation, it's fine. Just know that this is one of our other ways to show that the triangles are congruent. So if the side's not in between, you can use angle, angle, side. This would be the side that's between the two angles. This side is not between these two angles. Okay? Well, yeah, this connects to this line, this connects to this line, so the one in between would be the one where they both connect to. See, this connects to this line, but that one up there does not connect to this line. All right, so that would not be included. This would be the included one, but that's not what they told you. They told you that this side was equal to this one. So this would be angle, angle, side. Make sense? Okay. Let's do another thing. I'm going to give you a word that we've talked about before. Let's make a triangle, 3 sides. There you go. And I'm going to stretch this out a little bit like that. Come on, come on. Can't grab that thing. There we go. All right. So here's a triangle, and this side is equal to this side. We have a special name for that kind of triangle. Do you remember what it's called? Isosceles. Very good. Let's spell it. I what? Isos. It's isos, right? I and then the sos, S-O-S. Isos. And then what's the next letter? C-E what? Very good. All right. So let's all spell it correctly. All right. I've seen some wild, crazy spellings for isosceles, but let's make sure we spell it correctly. So it's an isosceles triangle. How do I know it's an isosceles triangle? What tells me? 2 equal sides. That's right. Okay. If I got 2 equal sides, it's considered an isosceles triangle. Now, this theorem, yep, it's a theorem. This theorem says this. If I have 2 equal sides, that means the angles that are opposite those 2 equal sides are also going to be equal to each other. I'll say it again. If I have an isosceles triangle, the angles that are opposite, let it sink in, those 2 equal sides, what am I talking about? The bottom 2. They're also going to be equal. Okay? You follow me on that? That's a theorem. It's like isosceles, say it. Isosceles triangle theorem, okay? So it says that if I have a triangle with 2 equal sides, automatically if the 2 sides are equal, that's isosceles, correct? So if the 2 sides are equal, what does the theorem tell us? Well, not just any of the 2 angles, but the 2 opposite angles. Do you see that? Look at this side right here. Which is opposite? That angle right there is opposite. Would you agree?
So it would be
The 2 opposite angles would be equal if the 2 sides were equal. All right? You see that? Those are opposite. That angle, let's put some letters in here, A, B, C, instead of saying that angle, this angle. All right, look at this. So look at AC. What angle is opposite AC? Angle B. What angle is opposite AB? Angle C. All right? So if AB is equal to AC, then angle B is equal to angle C. All right? That's what the isosceles theorem tells you. It's pretty easy, isn't it? And we're going to use it. It's going to come in handy. What we're doing is we're getting we're developing all these tools. You ever watch a carpenter or somebody that works on a building? They got a belt and they got all these things hanging off their belt, right? They got nails, they got hammers, they got all kinds of stuff, right, hanging from them. That's their tool belt. It's the same thing in geometry. We need some tools, right? The side angle side, the angle side angle, the angle side, all that stuff. Those are tools for us to use. The isosceles triangle theorem are tools that we could use. Knowing that all three angles add up to 180 degrees, that's a tool that we can use, right, to solve for missing stuff, right? You've already seen before, right? They put some x's in there, 3x plus 1, all that kind of thing. We have to have some tools to be able to solve for what they want you to solve for. This is one of the tools that we're going to use, all right? So if I see a triangle with two equal sides, what if they didn't even say those sides were actually equal? But what if they put numbers here? Oops. Let's get rid of that. Let's get rid of Let's get rid of that. Let's get rid of that and that. All right. So let's start with this. Everybody watching? What?
Okay. So why do they have to be opposites equal if they're all the same number? If they all
They're not all the same.
No, like if
Only two of them are the same.
Are the same, then why do they have to go diagonal?
Because
They're the same number on
So
both
that
sides.
side equals that side, but it can't equal that side?
Oh, I see. You're saying this should equal this.
Yeah, if that equals the other side.
I mean, yeah, I guess you got a point. But I'm trying to think of a counterpoint right now, and I can't think of one off the top of my head. But that's what we're going to think the opposite sides. Because, okay, let's say it this way. You're saying, oh, what about the one that's next to it? Well, what about this one? That angle right there is next to that 5, isn't it?
Yeah.
So how do I know I'm not using that one
But
is equal?
they're both 5.
Well, still, why don't I use that one?
I don't know.
I think that's a good counterpoint, don't you? So don't think of it like that. Don't think of it about, oh, the angle that's right next to that 5, because this angle right here is next to that 5. But that angle's not equal to any of the other angles. So don't think of it that way. Think of opposite. It's opposite because it's true. All right? It's not because it makes it easier, because it's true. So look, you look opposite. Are these two sides equal?
Yeah.
Yeah, because they're both 5, right? So automatically, what does that tell you?
That the bottom is 5 too.
That, see, B is opposite 5, C is opposite 5, so B and C would equal each other. Watch this. What if I said, that this was 40 degrees, and I asked you to find the other two angles?
Well, then the other one's 40.
Okay, this would be 40, right?
Why?
Yeah, why?
100.
Say it.
40 plus 40 is 80.
That's right, you got it.
180.
See, we're learning right in front of me. I can see it's not these light bulbs, it's the light bulbs on top of your head. They're coming on, okay? That's good, that's what I like to see. So this is 40 and 40, which is what? 80, and then 180 minus this 80 is 100, okay? All right, that's the kind of stuff we're gonna be doing. Now that was a very easy version of that. What could they possibly do? They could say, well, this is 2x degrees, right? And then this was 2x degrees. And then what would you do? And this was, well, I don't know. I don't know what.
Yeah, I don't know either.
Well, they'd have to give you more information. I'm trying to make this up off the top of my head, and I just can't make it up off the top of my head. But you know what they're going to do? They're going to eventually put x's in there. So let's say they said that this was, I don't know. Let me think. Yeah, no, not 3, 4. I don't know. I can't make this up off the top of my head to make it come out real nice and pretty for you. All right? Oh, I've got a fly buzzing around me. But you know what they're going to do. They're going to put x's in here and stuff like that, okay? So you would add all three, set them equal to 180, solve for x, plug it back in, and that kind of thing. All right? I just don't have that off the top of my head. This is the same kind of thing, what we're going to do right now, with a little bit of a twist. And maybe you see it coming. I don't know. What else do you think we could say? What if we didn't know those sides were equal to each other, but you knew something else was equal? What do you think? That's right. What if they told you, now remember on the other one, on this isosceles triangle theorem, they told you that the two sides were equal, so what did we know about the opposite angles? They're equal. What if they didn't tell you the two sides are equal? What if they told you that the two angles are equal? You got it. That's right. Then the opposite sides are going to be equal. It seems like the same thing, doesn't it? But it's not, because they give you different information. We call that the converse of the isosceles triangle theorem. Converse just means the opposite. Well, kind of. Not exactly, but it's close enough for us. I'll just shorten theorem to THM. Is that all right? All right. The converse. So this says, watch this. Let me show you a little bit. If the two sides are equal, then the opposite what? Angles are equal. That's what the isosceles triangle theorem says. What do you think the converse? What we do is we switch the if and the then. So this time we're going to say if what? If the two, not just angles. Yeah. Well, now you could say, you're right, you could just say that. If two angles are equal to each other, then the sides opposite are going to equal each other as well. See how we switch the if and the then? This one, if the two sides. This one, if the two angles, right? This one said, then the opposite angles. This one says, then the sides. If the two angles are equal to each other, like B and C, then what does that mean? Then the sides opposite those two angles are also going to be equal to each other. So watch. Here, I'm going to write it down another way. If AB was equal to AC, then what could we say from this theorem right here? Angle B equals what? Angle C. How would I write it? How would I write this one? If angle what? B equals angle C, then AB equals AC. Just see how I switched? Do you see how I switched the if and the then? All right? So instead of it being if AB is equal to AC, now it's going to be what? If BC equals angle C, or if angle B equals angle C. Right? Instead of saying angle B equals angle C, what did I say here? AB equals AC. It just means the same thing. Don't worry about that too much. You're reading too much into it. I thought that would be a little easier for you, but I'm keeping it there. Don't worry.
That's a lot of letters.
All right, we good with that?
No.
What?
Guys. Sorry, hold on. Wait, just give me a second.
If the two angles are equal, if B and C are equal, look, this is basically the same thing as this, except I went real specific and told you the names of those two angles. Okay? So if two angles are equal, then the two opposite sides are equal. Here's the two angles that are equal. Here's the two opposite sides that are equal. That's all I did. Shouldn't be that confusing. All right. It'll be on video, so go back and watch it if you didn't write it down. One last thing and we'll be finished, okay? We've actually talked about this, so you should be familiar with this. Remember I said later on we're going to talk about it? Well, guess where we are?
Later on.
We're later on. That's right. Okay, so let's take a look. And this kind of goes with what we just talked about. It really does. That's why they do this last and they do those other two first. This right here is a equilateral triangle.
Spelling on that?
Equa, E-Q-U-I, and then lateral. You can spell lateral, can't you? Lat, E-R-A-L, lat-er-roll. And then equa, E-Q-U-I. I'm going to write it down in a minute. So check this out. What does it mean to be equilateral? All the sides are equal. Good. Now, do you remember what we hinted at? We didn't really hint. I told you what was going to happen. But here is officially where we learn this. All right? So if it's equilateral, it's also going to be equiangular. Let's see why. Because of what we just learned about that isosceles triangle theorem. So check this out. Look, A and B are equal. Or sorry, AB and AC are equal to each other. So what does that mean? It means angle B and angle C are equal. Would you agree? So they both get one arc. Check this out though. Look, BC, everybody watching?
Yeah.
BC and AC are equal to each other. So these two sides are equal to each other. So guess what's true about the opposite angles to those sides? They got to be equal. So if that has one arc, then this has got to have what? One arc. So if all three sides are equal, then guess what? All three angles are equal. You got it. All right? So here's the thing. If it's equilateral, then I'm going to put arrows going both directions. If it's equilateral, then it's also what? Equiangular. I put arrows in both directions because I could go the other way, couldn't I? What if it was equiangular? Then it would be equilateral. Got it? Now, we learned something the other day that we're going to talk about right here, and then we'll be done. If all three of these angles are exactly the same, I could actually tell you the actual degrees of those angles. If all three of these angles are exactly the same, I can tell you exactly how many degrees each angle is. Right, 60, because they all add up to what? They all add up to 180.
Basically, all the sides equal and all the angles equal.
Yes. That's what that means. Equilateral is equiangular. Okay? But I want to, listen, I want to find each of those angles. I didn't give you any numbers at all, did I? Right? I didn't say one angle is 30 like we did on the other one. I didn't tell you anything about the angles. All I said was all three angles are equal to each other. But I could figure out what each angle is now. All right? So how do I do that? Well, they all add up to 180, and all three angles are exactly the same. So I take that 180 and I do what to it? Divide it by 3. And what is that? 60. So that means this angle is 60 degrees. This angle is 60 degrees, and this angle is 60 degrees. Another tool for our tool belt. We're going to use this. Okay, they're going to ask you some problems. Sometimes they get a little bit complicated. This is one of the things you got to look for. If you have an equilateral triangle, you know that all three angles are 60 degrees. Okay? It's a lot of stuff to keep in your mind. It's got to keep building up, building up. Go back, watch some of the older videos every once in a while, just to kind of keep up with this stuff. All right? It all builds, 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 builds. Like any math class. All right. I think that's good. So let me give you a little assignment. So section 4.4. Now write this down carefully because I do skip around a little bit on this. Yes. Well, that's coming up, isn't it? Okay. So I skipped a little chunk in there from 13 to 17. So you're doing 1 to 12, and then you're jumping up to 18 and 19. All right? So that is your homework. I'll put the page 172, 173. And there you go. Everybody good?